Hi team, I'm back again to explain the Java applet for the solution of a system of linear equations. It is found in 4th week. If you click the link to the Java applet, it will take a moment to appear, the Java applet. Assume that you have already installed Java. As I explained in the previous applet, you need to install Java. So the first equation is shown like this by a green color, and the other equation, the graph of the other equation, is shown by the purple line. So essentially in this case what you do is you can vary the coefficients of the equation, and when you vary the coefficients of the equation, you see the equation changes here, and also the graph of the equation changes. And the intersection point for the two lines is automatically also shown here. So actually what you do in this case is by changing these parameters and changing this equation, you will find the intersection point. For example, these two equations, 2x plus 0.8y equals 6 and 2.4x plus 2.4y equals 10. The two meet at a point. That point is 2.22 and 1.94. So if you have any given system of linear equations, you can just define those two equations by moving these sliders, and once you have moved and identified your equation, then the intersection point gives you the intersection point or the answer to the solution of the systems of linear equations. Well, it is interesting that this is a very simple but effective way to give us an idea of what we mean by solutions of systems of linear equations using graphing method. So I hope that you will take your time to experiment with different solutions. Now let me say that supposing we have a system of linear equations which is producing parallel lines. For example, this is 2x plus 0.8y is equal to 6. Now deliberately let me make this one, you see, this one, let me make it 4, and this one 1.6, let me make that one 1.6. yeah, and then this one I make it 12. See, it means essentially this equation and this equation are the same. What I did is this is a multiple of the other one. 2 times, if you multiply the whole equation by 2, you will find that the two are the same. It is 2x is equal to 4x, 1.8y is 1.6y, 6 times 2 is 12. So it is actually the same equation. So the graph or the line of the two equations are coincident. Therefore this is a case where we say that the two have infinite solution. If you solve this linear equation, system of equations, you will find a situation where you find like something like 0 equals 0 or 5 equals 5. That is something which is true all the time. The other case that we have been considering is that if two systems of linear equations have the same slope, then if they have the same slope, then they are parallel. So let us try and make system of equations which are parallel. Let me just take this to 1, to a value of 1. Actually I can change the value here, make it 1. So 2x plus 1y is equal to 6, and let me make that one also 2. Okay, make this one 2. Okay, I did it deliberately again. Make it 2y and in which case the slopes are going to be the same, but the values I'm going to change the value of this one. Even if the slopes are the same, you see, the slopes of these two equations are the same. The slope is -2. I deliberately made the slope equal to -2 for both. And when you check out this, you will see that the two equations are parallel. So you can take your own cases of equations satisfying the three different cases. The three different cases that we have learned is the two lines intersect, in which case they have one single solution. Then the two lines, the other case is the two lines are coincident, then we have infinite solutions. And the third case is where we have the slopes of the two equations are equal, or the two equations, the graphs of the two equations are parallel, in which case we have no solution at all, because these two lines, there is no chance for the two lines to meet at all. So you see, you can actually, when you experiment with this graph, you will have the feel of what we are trying to talk about regarding solutions of systems of linear equations with two variables. Actually, in this week we have a lot of ground to cover. We have other areas like systems of linear equations with three variables. In fact, if you look at clips like this, and also if you look into YouTube, there are a lot of very interesting examples there are many educators out there who are developing lessons like this and posting it to the YouTube. So if you access the YouTube, you'll get lots of lessons which will be helpful for you to really have a good grasp and understanding of the underlying concept. Thank you and bye bye.